We solve linear inequalities exactly the way we solve linear equations. That means whatever we do one side, we must do it to the other side as well, except that if we multiply or divide with a negative number, we must flip the sign. Why is that? Because think about 2 is less than 3, right? That is a true inequality. But if I go ahead and multiply both sides with a negative, negative 2 and negative 3, negative 2 is not less than 3. Negative 2 is actually greater than 3. So if I multiply both sides with a negative, the sign of inequality flips. That's why keep in mind, anytime we multiply or divide with a negative number, sign of inequality flips. So here's our first example. To solve this inequality, we want to isolate the x. First step would be to distribute the 3 in there. 3x plus 6 less than equals 2x plus 10. Now I'm going to try to bring variables on one side, so I'm going to subtract 2x from both sides. X plus 6 less than equals 10. X less than equals 10 minus 6, which is 4. So we can write our solution in the interval notation and we can also graph it. This is where 4 is. And all the values that will satisfy this inequality are to the left of 4. We can draw an arrow in the direction of the left-hand side. To write our solution in the interval notation, we can say our solutions are from negative infinity to 4. Next example, negative 2 greater than equals 1 minus x over 2 greater than equals negative 10. Let's multiply everything with a 2, all three parts of this inequality. So leaves me with negative 4 greater than equals 1 minus x greater than equals negative 20. Now we're going to go ahead and subtract 1 from everything. That's negative 5 greater than equals negative x greater than equals negative 21. Now we would divide everything on both sides, everything on all three sides with negative 1. Remember, when we divide with the negative number, the sign of inequality flips. So it's going to be 5 less than equals x less than equals 21. In this case, my solution is going to be between 5 and 21. And I'm going to shade inside because this entire region is my solution. And writing the interval notation, both 5 and 21 will get the brackets. 5 and 21 will get the brackets. Next example, we have a bunch of fractions here. So my first attempt is to clear all the fractions. I'm going to multiply everything on both sides with the LCD. Multiply by 12. You could work with fractions, but I personally prefer to clear all the fractions. So I'm going to multiply every single term on both sides by 12. Right, and that leaves me with 3b. 12 times 1/4 is going to be 3b. 12 times 2/3 would be 8b plus 8b. And 1/2 times 12 is going to be 6. Plus 1/2 times 12 is going to be 6b plus 1 plus 12b. Let's go ahead and combine the like terms on the left-hand side. 3b plus 8b is going to be 11b minus 6 greater than 6b plus 6 plus 12b. 11b minus 6 greater than 18b plus 6. Let's bring the b's to one side. I'm going to go ahead and take them to the right-hand side because that will keep my b's positive. 18b minus 11b will be 7b. And I'll be bringing 6 to the left-hand side. So I'll be subtracting 6 from both sides. Negative 12. Now divide both sides with 7. Negative 12 divided by 7 is greater than b. Or we can say b is less than negative 12 divided by 7. Now let's go ahead and write it in the, let's go ahead and graph it and also write it in the interval notation. So in this case, there's no equal sign. That means I will be using open parentheses when I graph. Negative 12 over 7 is like negative 1 point something. It's close to negative 2. So this is negative 1. This is negative 2. I'm going to say negative 12 over 7 is here. My solutions are b is less than negative 12 over 7. So I have to mark it the other way. All the values less than negative 12 over 7, which will be here. So all the values to the left of negative 12 over 7 will be my solution. And to write in terms of interval notation, I would be using parentheses in this case, no brackets, negative infinity to negative 12 over 7 with parentheses. Sometimes it's impossible to isolate the variable. For example, in the next inequality. In that case, I'm going to separate it into two inequalities, and wherever I have the overlap, that would be my solution. So negative 3x less than negative 2x and negative 2x less than negative x. So go ahead and add 2x to both sides. Negative x less than 0. And that would give me x greater than 0. And if I add x here, negative x less than 0, which would be again x greater than 0. So from both of these, I am getting an indication that 0 to infinity is a solution. But if I was getting different solutions from both, wherever the overlap is, that would be my solution to the whole inequality. Because it has to make both of these happy, both of these individual inequalities happy, not just one. Right, next one. Again, it's impossible to isolate the x here. No matter what we do, we won't be able to isolate the x because all three parts have x's in it. So 2 minus x is less than 3x plus 1, and 3x plus 1 is less than 10x. Let's go ahead and take the x to the right side here. 2 less than 4x plus 1, subtract 1 from both sides. 1/4 less than x, or x greater than 1/4 is the solution from the first part. And the second one, 1 less than 7x, so we can subtract 3x from both sides. 1/7 less than x. Let's go ahead and graph these solutions, and wherever they overlap, that's going to be my solution to the inequality. So the first one is telling me x is greater than 1/4. This is where 1/4 is. All these points satisfy first inequality. And 1/7 is here. So second inequality says 1/7, everything to the right of 1/7 is my solution. So for us, we want the solution to make both of these inequalities happy, which is going to be everything to the right of 1/4. So my solution is actually going to be, let's redraw it, 1/4, and there would be parentheses around 1/4 and values going to the right. Okay, in terms of interval notation, it would be 1/4 to infinity. That would be the solution to this inequality. That's all for linear inequalities in one variable.